Okay, here's the next related rates problem that we're going to be doing. Sorry, it's going to involve a baseball field, and what we're going to be looking at are the related rates for base runners. Now, just a little information for those of you who don't know: baseball field standard baselines are 90 feet. So the distance from home to first is 90 feet, distance from first to second 90 feet, second to third, third to home, all 90 feet. So it's a square. We usually don't think of it as a square though, because we usually think of it as tipping it on one of its vertices to create a diamond. So therefore we usually call it a baseball diamond. But it's really just a square that's been tipped over, okay? Which of course means all of the angles at the bases are 90 degrees. Now this problem that I'm offering you has two parts, one involving second base and one involving third base. So I'm only going to do one half of this. I'll leave the other half for you guys to work through. So let's go ahead and talk about maybe letter A. Now the problem says that a player can run the bases at a rate of 15 feet per second. Now one non-realistic thing that we're going to do is we're not going to round any of the bases. We're going to run a straight line from home to first. We're going to run a straight line from first to second, second to third, third home. We're going to run straight lines. In reality, of course, we might be rounding off the bases if we were trying to go from home to second, if we hit a double, that sort of thing. But we're going to run straight lines. Okay, and it says again in the problem that a player can run the bases at a rate of 15 feet per second. The question is, at what rate is the player's distance from home plate changing when they're 30 feet from second? So that means then that we have a player on first, and they are running towards second base. If I can get my screen from jumping around here. Okay, so we have a person on first, and they're running towards second base. Okay, we know what rate they're running at because the problem says this person has the ability to run at 15 feet per second. Okay? Now, we're going to look at the instant when the player is 30 feet from second base. So we're going to look when this distance to second is 30 feet. And the question posed in the problem is, at what rate from home is the player's distance changing? So we're focusing on the distance from home to that player. And I didn't mean that to be in red. I meant to have that in black, so let me switch it. So from home plate to wherever that player is, at what rate is that distance changing? So if we call this H for distance from home, okay? And that's going to be changing, right? That H is 90 feet when the player is standing on first. And then when the player takes off from first towards second, of course, the distance is increasing. Because it's increasing, because it's changing, we need to assign a variable to talk about that side, okay? To talk about that distance. We also need a variable to talk about the distance the player is from first base, and I'm going to choose to use an F to stand for the distance from first. Of course, when the person is standing on the base, the distance is 0. And when they get all the way to second, the distance is going to be 90. But of course, we're looking when the player's 30 feet away from, when the player's 30 feet away from the base. Okay? Alrighty. So that's the idea, right? And so what we have to do is come up with an equation that relates what's going on. Now we have two choices. We can, number one, use the triangle formed by the distance from home to the player, back to first, and then the first base line. All right, so we could use that triangle. And I might ask, if I was in person, what's the advantage or disadvantage of that triangle? The other triangle we could potentially use is using the triangle formed by home to second, back to the player, and then the distance between home and that player as they make the run. Right? And again, advantage, disadvantage of that one. Okay? So we need to pick one of the two. We can't work with both at the same time. We need to pick one of the two. All right? Now, if we pick the purple triangle, you would need to then tell me an equation that relates those distances. And what do you know relates those distances best? Probably law of cosines, which involves trig functions and lots of variables all over the place. So that would be fine if you want to do that. But if I do this in reverse and get rid of the purple so it's no longer there, what would be the advantage of using the blue triangle? The advantage there is that since this baseball diamond is actually a square, the angle at first is 90 degrees, which means we'd be dealing with a right triangle. We'd be dealing with a right triangle. And that's the one I'm going to choose to use. I'm going to choose to use that triangle. Okay? So what equation, what formula describes that situation? Right triangle, and we're looking at the sides. Pythagorean theorem. And so what we're going to have then for our initial formula is f squared plus 90 squared is equal to h squared. Leg squared plus leg squared equals hypotenuse squared. Please notice across from the 90-degree angle is the hypotenuse, and I happen to call that one h. Okay? So there's our equation. Okay? Can you take the derivative of that? Of course. The derivative of f squared is 2f, attach the differential, which would be df. The derivative of 90 squared would be 0, and the derivative of h squared is going to be 2h dh. Divide everything by dt. Hope this is starting to feel familiar. So divide everything by dt. 0 divided by anything just goes away. And then how do you know which derivative to solve for? Well, the question in the problem was, at what rate is the player's distance from home plate changing? So the one we're searching for, the one that we're asking you a question regarding, is going to be dh dt. So that's the one we want to get by itself, which isn't very difficult. To get rid of what's attached, the 2 and the h, we just simply have to divide both sides by a 2 and an h. I'm going to take an extra step and just cancel out the 2's. So our rate formula then is going to be dh dt equals f over h times df dt. Right? And there is our rate formula. Okay, what is f going to represent? The distance the player is away from first. So at the instant that we're asking, the player is 30 feet away from second, which means they're how many feet away from first? Okay? H is the distance from home plate to where that player is at that instant. And df dt is the rate at which the player is running. So I'll leave the rest of the problem to you, which of course is asking you for dh dt under those conditions. Okay, that's part A. That is part A. Part B, you guys are going to have to adjust because now we're asking the player continues to run and is now 30 feet from third base. And so you're going to again have to decide which triangle to use. You're going to create a triangle placing a person 30 feet away from third base, and you have to decide how to draw the triangle. Do you want to draw a triangle to second, or do you want to draw a triangle to third base? So try and decide for yourself. Okay? So I hope this helps. Help each other out a little bit if you need to, want to. Otherwise, please take a look for the last video that I'm going to put online to help you out with your worksheets. Okay? Hope you're having a good day, and we'll talk to you soon.